Scientific method and celestial bodies. Welcome to this series about scientific reasoning and critical thinking. In this first of 4 episodes, we will get acquainted with the scientific method. This may sound difficult, but it isn't. The scientific method is made up of simple steps like looking around to see how things work and trying to solve problems. This is what we humans have always done to make progress. Like when we learned about finding food. We tried fishing at one place, and if we didn't catch anything, we moved on. Later we experimented with different kinds of bait and rods. And finally, when farming, we'd see which crops were suited to different kinds of soil. And when we saw what worked the best, that's what we planted. Early man used trial and error, but they had no idea that this was a kind of scientific method. And in many ways, there was a long way to go before we reached the point of scientific reasoning. If your crops failed or other disasters struck that were hard to understand, you might blame it on the planets, that the stars were crossing you. In time, we would observe the heavens more scientifically and find the real story. 2,000 years ago, the Greeks were first, and Ptolemy was the foremost. His studies showed that the planets moved in specific orbits. This was an important discovery, even though certain conclusions were wrong, such as placing Earth at the center. Ptolemy was the main proponent of the superstitious belief that the planets had power over us. Ptolemy founded 2 disciplines, astronomy and astrology. The difference in the names is only 2 letters, but today there is a huge difference in what they stand for. Astronomy is the science that describes the planets, the stars, and outer space. It's based on observed facts. Astrology is make-believe, fortune-telling, which may be entertaining, but that's all. We won't get it right about the planets and the sun until the late 1500s. This is thanks to a man called Copernicus, who realized the sun was the hub around which the planets revolved. This was a bold thought at this point in time, that Earth wasn't the center of the universe. And this way of building on previous discoveries is what makes the scientific method so efficient. It creates progress. Progress takes a sudden leap with Galileo Galilei. He made the first telescope. Now he could look at the world in a whole new way. He could show that the planets revolved around the sun. And he discovered new celestial bodies as well. Galileo believes that explorers should not be ruled by emotions or by preconceptions, or by anyone in authority, such as political or spiritual leaders. They are not to determine what is the truth. Instead, it's vital to maintain an open mind, experiment, and examine what you observe. Aim for objective conclusions, and have the courage to see what is new. The discoveries by astronomers led to a deep mystery. What keeps the planets in their orbits? Isaac Newton provides the answer. In the late 1600s, it's said that Isaac Newton was struck by a brilliant idea when he saw a falling apple. What if the force pulling the apple to the ground is the same force that affects the planets? All this was merely an idea on paper at first, a hypothesis. To find out if a hypothesis is true, we need to test it. This was tested by measuring how strong the pull of the moon is on the sea. The variations in the tide at various places around the world were recorded. If the hypothesis doesn't tally with the results, you have to start all over again. But if it does, like it did with Newton and the tide and many other tests of Newton's ideas in gravitation, the hypothesis goes on to be a theory. In this case, the theory of gravity. A scientific theory is something that holds up to repeated testing. It's what we would generally call knowledge. In the early 1900s, Albert Einstein builds on Newton's theory of gravity and adds a new twist, that celestial bodies might have a pull on light as well. His hypothesis is tested during a solar eclipse in 1919, when scientists could detect a star hidden by the sun. Because the light from the star bends around the sun and reaches Earth. This confirms Einstein's hypothesis and the validity of his theory of relativity, which predicts many new concepts. Einstein believes that a body with enough mass not only bends light, but also swallows it, thus predicting black holes in the universe. Einstein's theories are important in our everyday lives as well. GPS clocks would go out of step, placing us 10 kilometers off on the map for each day, if it weren't for the theory of relativity. Without Einstein, we would be lost. But while science was finding out about space and the planets, what was going on with the pseudoscience, astrology? We left it 2,000 years ago, and not much progress has been made. It still revolves around fortune-telling about love and riches. Our knowledge of the universe, however, has taken a giant leap. Thank you, scientific method.